Nice. So code completion, obviously, we know that's hugely valuable today as a part of these general purpose LLMs that are out there. I already mentioned some of them: Claude, ChatGPT, DeepSeek algorithms are making a lot of a splash right now at the time of recording this episode. And another valuable, and I've been using it a lot, code completion tool is Google Gemini. So Google Gemini is a great LLM, and you were on the Google Gemini team. You were working on code generation as a part of that team, I think, as well, right?
That's right. That's right. I was part of Gemini from the start. I was a core member of that team, and yeah, I was on that team right until recently when I left Google. And yeah, it was certainly an exciting time, and it was cool. It was a lot of fun.
Yeah, it must be amazing to. I mean, yeah, you don't need to go into actually any detail yourself, but I can imagine that it would be amazing to be working on the team that would be right at the cutting edge of what AI systems can do. So at the time of recording, for example, I'm looking at the LM Arena, which allows people to rank outputs, and statistically tied for first at the time of recording as the best general purpose LLM overall, aggregating across a ton of different metrics, is Google Gemini 2.0 Flash, Google Gemini 2.0 Pro, ChatGPT 4.0, and DeepSeek R1. And if you're willing to go beyond just those 95% confidence intervals, the statistical evaluations that give us that four-way tie in first place overall would be Gemini 2.0 Flash. So it's pretty cool to see that. I mean, you don't need to go into any more detail, but I'd imagine I'd be very proud if I was working on something like that.
I mean, I was just one person in a large team. Like it was a lot of fun. It was a really cool experience, and the people there are really cool.
And so I also know we can't go into very much detail on specifics, but I was curious to know because I was talking to you prior to recording about particular PyTorch libraries, like PyTorch Lightning, which is something that I regularly use. And it seemed like you hadn't even heard of PyTorch Lightning. And I was like, what? How can Varun not know PyTorch Lightning? And then I was like, oh, yeah, of course, because PyTorch is a meta product. And so probably Google doesn't use it. And I was like, oh, you guys all using TensorFlow? And you were able to inform me that that isn't actually mostly what
Yeah, a lot of people use Jax, and there's actually Jacob Austin recently just posted a really great guide or tutorial on scaling models on TPUs, and Jax and TPUs are used heavily inside of Google for modeling. Um, and yeah, like so yeah, I've been at Google for a while, and so I'm a bit ignorant of what's happened outside, because it's like you're in the day-to-day kind of sprint mode of doing stuff. And I think especially in the last few years, it's been, at least for me personally, kind of overwhelming working on machine learning, because it's like every few weeks some insane new announcement happens somewhere in the world about how someone has done some amazing new thing. And honestly, like 5 or 10 years ago, it was a much simpler time in machine learning. Like now, it's just like seemingly every week something is happening, and so yeah.
it is pretty wild. It is a spin. It When I first started hosting the show 4.5 years ago, I didn't always every week have like some breaking story that I felt like I need to talk about. So sometimes regular listeners will know that I do 2 episodes a week. There's a Tuesday episode, a Friday episode. The Tuesday episodes always have guests. They're longer. They tend to be about an hour long. And then on Fridays, there's a lot more flexibility. When I took over as host from Kirill Aramenko, who had been hosting the show for the first 4 years, he called Fridays 5 Minute Fridays, and they were these short solo episodes. And he would talk about, kind of life philosophy advice in a lot of those episodes. And so I kind of carried on that tradition. But part of why I was carrying on that tradition and kind of talking about habits you might like to develop or how to stay on top of your habits was because there wasn't always something new for me to talk about in data science and machine learning. And now that's never the case. There's always so much that I could be talking about in Friday episodes. And I think it's been a couple of years now since, sometimes I'll have guests that are tangentially related on topics like we had an economist on a few months ago, Nat Ware, to talk about why people aren't aren't happy all the time, despite it being such a great time to be alive compared to history. And so, I try to have interesting episodes like that sometimes with guests. But when it's me solo, I'm pretty much always doing research on a particular data science topic, and that means usually today a machine learning or AI topic. I'm not doing that many episodes on like a new data visualization technique.
Right, right. It's been insane. And I think it points to, I think there is genuinely this Cambrian explosion happening underneath us. And I do think that LLMs or just machine deep learning in general, but LLMs are just one of the most profound things that I've seen happen in computing, certainly in my short career. But it's when I look at history, or I'm just interested in the history of computing, like it's just insane what we've seen happening. And it's just really fascinating how the way LLMs have even transformed machine learning itself, where like one way you can view LLMs, or one way that I view LLMs, is that they're sort of arbitrage of ML talent, where it's sort of in the past, if you wanted to be an ML engineer, you needed to learn PyTorch or JAX or whatever. You needed to learn how to collect all this data. You need to like, if the goal you were trying to solve was to put intelligence, quote unquote, into your product. And now, seemingly, what's happened is that you kind of need to be able to articulate the behavior you want in clear English in a prompt and have good evals to measure and characterize the performance of that inference call. And it's sort of fascinating how it's turned so much of what used to be bread and butter machine learning into just prompting. And it's just fascinating how different the skill sets required seem to be for prompting effectively from the skill sets required for kind of training models effectively, and kind of and that's something I've been interested in for a very long time, is like how, like, what does it mean to be in a world where you can sort of take inference for granted, kind of thing, right? Like you can build systems on top of plentiful inference calls. And what does it mean to be able to systematically tune your prompts and systematically manage your prompts as the models get better? And that was actually one of the last things I published before I left Google, which was a playbook for prompting. And the playbook actually has two parts to it. The first part is sort of like my high level thinking, like my high level mental model of how you can think about pre-training versus post-training, and how you can think about prompting. And the second half is kind of clear prescriptions on this is what a good prompt looks like and this is what a bad prompt looks like. But I think, as I mentioned in the playbook, I think the first half is actually much more interesting and future-proof than the second half, because the second half is written from where the models are today. Like prompting O1 or Flash thinking feels, at least to me, qualitatively very different than prompting 4.0 or just Gemini 1.5 or something like that. But at the same time, but that difference, I feel, is in the surface level form of the prompt itself, as opposed to the mental models I have of what is actually happening under the hood in how that prompt is getting translated into computation. And obviously that's a little inscrutable because it's a model under the hood, but that's kind of what the first half of that tuning playbook tries to grapple with, is how you can kind of think about that. And the way I kind of approach that is by explaining to people that, and this is where it kind of gets a little philosophical, right? Because it ties into some of the things I've been doing recently, which is LLMs are sort of anything machines in that they're general sequence to sequence machines, right? And nevertheless, when you ask an LLM to give you an answer, like if you ask it, how old is John, or like how old is some celebrity, it'll give you an answer. But the thing is, this thing is not an embodied thing in the world. It's getting its factuality from kind of the data sets that's been trained on and so forth. And so that's kind of what that playbook tries to explain, is that one way you can think about it is that there is no such thing for the purposes of an LLM of an objective fact. So, for example, for the Lord of the Rings fans out there, say I come up with a proposition: Aragorn is the king of Gondor, right? Well, actually, John, are you a fan of Lord of the Rings? I don't know if
I have watched all of the Lord of the Rings films
okay.
many, many years ago, and I read The Hobbit. I didn't like reading The Hobbit.
That's
I
fine.
found it I found it dull and linear.
Okay,
But
so let me ask
yeah,
you this question then. Is Bill, like, suppose I come up with the proposition Bilbo Baggins is a hobbit, right? That's my statement, right?
mhm,
Is that true or
mhm.
false?
I would say it's true.
Okay, show me where is Bilbo Baggins? Show me where Bilbo Baggins is.
He's in the Shire.
Shire isn't real, man. Where is Bilbo? How could it be true if the Shire isn't real?
J.R.R. Tolkien is the god of determining what is real in the Shire.
Right, right. So in the world of the Shire, it's true, but on Earth, it's like not true unless we're saying fiction is somehow real, right? And the point there is that every proposition you make has a certain backdrop of assumptions behind it. And so that's why, like in the playbook, I called it cinematic universe, because people are used to that idea now, right? Because there's like different cinematic universes. There's like the DC, there's the Marvel, whatever. But the point is that the truth value of Bilbo Baggins is a hobbit is contingent on which cinematic universe you're in. If you're in the DC cinematic universe, that proposition maybe doesn't even make sense. It doesn't even have a resolvable truth value. In the cinematic universe of The Hobbit, it kind of does, like it does, right? And in the cinematic universe of the Earth, it doesn't. So now, what happens when you take a sequence to sequence model, right? And one way you can think about it, or one way I think about it, is that the internet, or like all of written text corpora or something like that, are an approximation of the set union of all cinematic universes in existence. And the issue is that if you train on all of these things and then you do next token prediction on that, like on a statistical model based on that, there'll be many modes in that distribution, right? But the model, like, but the mode you care about, that is the cinematic universe that you care about, might not be the mode that the model has like fitted to, right? And so we've just described pre-training, and so that's the problem with pre-training. And so what you need to do now during post-training is you now need to shape that distribution to the one you actually want, with a specific cinematic universe where there are always two participants. One is the like AI assistant. One is the human. The model does not have access to the internet. Like there are some assumptions about the model's like interaction with the world. There are some assumptions on who the user is. There are some implicit and tacit assumptions about what is or isn't a fact. And so that's why I think that if you give a pre-trained model, or any model, like an unspecified prefix like hello, how are you, you just, unless you've post-trained it properly, you just get a nonsense generation, because it doesn't know like which cinematic universe you're in, right? Or if you ask it how old is insert celebrity name, it doesn't know if you're talking about the real celebrity. Are you talking about some fictitious universe? Are you talking about when that proposition was true, like X years ago? Are you talking about now? Like, there's actually a lot of cognitive scaffolding necessary for all of this humanity to work, right? And so the playbook, the first half of the playbook is kind of, it's an attempt. I don't know if I succeeded to kind of explain this a little bit more, and then that informs the way you think about prompting, because then the implication of that is that one way to think about prompting is like, well, for post training, the data for post training comes from human rated, right? Like that are like creating demonstrations for it. So one way to think about what these post train LLMs are is that they are AI, they are statistical models role playing as human raters that are role playing as AI assistants. Does that make sense?
Yeah, that does make sense.
And so when you take that a step further, it's like, okay, how do you prompt a model effectively? And this is where, like, people I've seen on the internet are also talk about, like, it's all about putting the right context in the model. And I think that's true in some reductive fashion, right? But really what we're talking about here, or one way to think about it, is say you write down a prompt and imagine if you just picked off a person off the street, right? And now this person has access to the sum of all of human knowledge, but it has no idea who you are. It has nothing. It's like, imagine if when you put a prompt, there is a person picked off of the street who has access to the sum of all human knowledge, and every time a prompt comes in, they're going to read the prompt and they're going to read the data you put in the prompt, and then they're going to decide like what the response is. So when you frame it that way, obviously that's not happening under the hood, but when you frame it that way, what would you actually put in the prompt? Right? Like, how would you communicate to such a person effectively? Right? And I found that when people, like, there's this funny, like, the rubber ducky effect, where it's like, before you like come to me for advice, try to like explaining your problem to a rubber duck. And then what I found is when people complain that, oh, like my prompts aren't working, and they're like rattle off all the ways it's not working and all the ways that the model doesn't understand what they want. And when I tell them, have you tried just taking these complaints and putting that in the prompt? And usually the prompt does way better, right? Because another way to think about it is, I linked to it in the playbook, is there's a Wikipedia page about this. I believe like sociologists or something call it like the difference between high context and low context cultures, like forms of communication that are much more explicit versus forms of communication that are much more implicit. I've found that the most effective way of prompting these models is to be extraordinarily explicit with them. And another book I really recommend in that playbook is Nonviolent Communication, which I learned off in therapy and couples therapy. I didn't do couples therapy to get better at prompting models, but needless to say, for all the viewers out there, but it turns out that effective interpersonal communication and being explicit with what you want in terms of observable behavior from another person is actually not that dissimilar from being more effective at prompting these models, right? And so anyway, all that's in the playbook, and that sort of like shaped a lot of that. I've been thinking about like just cognition for a while, and then that sort of like shaped the things I've been thinking about for the last few months mostly.